All right, on the second section, we're dealing with solving equations and matrices and how to solve equations simultaneously, like 3x3 equations and 4x4 equations with matrices. Okay? Now, to set this up, here's two equations. Here's two equations. So the matrices you set up are 3 and 16, 1, negative 5, times x, y equals negative 4 and 1. Okay? That's the matrices you set up when you're solving equations. So, they ask in the second question, what would the equations be? Well, remember, in multiplication, we take a row by a column. So it's 2x minus 3y equals negative 3. 2x, Mr. Bierschbach, thank you. And then 3x plus 4y equals 2. Okay, that's your equations. And now they say solve this. So we're going to solve this. So we're going to take the original matrix is 1, 2, 2, 2. Okay, times xy is going to be equal to 10, 14. So now what we want to do to solve this equation is we want to put this onto this side. Okay? So we're going to write the inverse of it. But instead of doing the long drawn out inverse of it, we're going to get out our graphing calculators. And we're going to do matrices solving on our graphing calculators because everything we've done so far with matrices in this classroom, we can do them on our calculator except for some of those problems where you had to get down to 0, 1, 0, 0. But when you take the test over this chapter, you can do everything on your calculator using the matrix buttons and so on, which you were already doing earlier. I saw you. So, which is fine. But if you go second and then x to the negative first power, second matrix, the one right below the math, it comes up with this. And so I'm going to name my A matrix. I'm going to edit my A matrix. So I'm going to bring up the matrix button and then scroll over to edit. So push the right arrow key twice. And then I want a 2 by 2 matrix. Okay? And my 2 by 2 matrix, I'm going to put in my original one, which is 1, 2, 2, 2. Okay? And then I'm going to quit out of this. I'm going to go second quit. So if I just look at my A matrix, and it's easier to see when that's off, you see I have a 1, 2, 2, 2. It made it right. It made it correctly. Now, if I go, sorry about that. If I go A inverse, so if I go second matrix A, and then second matrix, and then go to the math, I tell you, some days. I thought I had an inverse button. I can just do inverse really easily by going second, or not second quit. I can go inverse by just hitting the -1 button. And there's my inverse of it. Okay? So that's how to get A inverse, by hitting this button right there. Okay? A and then that inverse button. Okay? So what is A inverse? Well, it's -111.5. Okay? So how do you solve this using that? Well, you're going to type in A inverse B. So you're going to take A inverse here and take it times a B matrix. What's my B matrix? Well, it's going to be my 10, 14 matrix. So I'm going to have to go second matrix again and build a B matrix. I didn't build it yet, Mr. Bierschbach. You got to go over to edit, down to B, hit enter. So I got 2 rows, 1 column. The first row is going to be 10, second row is going to be 14. And if I quit out of here and I hit enter on my AB, the answer is going to be 4, 3. X equals 4, Y equals 3. So 4 plus 6 equals 10, and 8 plus 6 equals 14. I solved my equations simultaneously using a graphing calculator using matrices. Okay? All right. Now we're like a 2x2 matrix. Doing it on the calculator doesn't save a lot of time because you got to go this to this to this to this. Where you save time is solving 3x3s or 4x4s, because the calculator can really save you a lot of time versus trying to do them by hand. So let's do this one. It says by doing row echelon form. Yeah, no, not going to do that. We're going to do our handy-dandy graphing calculator. So I'm going to go second matrix, A. No, not A yet. Second matrix, edit A. I forget to hit edit all the time. And it's going to be a 3x3 matrix. And I'm going to put the matrix exactly the way it is here. I'm not going to try to inverse it in my brain and type that in. I'll let the calculator do all that work. So I'm going to type 1, -2, 1. Question, Maggie? Because we're just doing this side as one matrix and this side as a separate matrix. Okay? Now earlier today, we're doing a 3x4 when we were doing that row echelon form stuff, which was a pain in the butt. Okay? So this, using the graphing calculator, we're doing a 3x3 and a 3x1. So 1, -2, 1, 3, -4, -3, -2, 1, 8. Okay? Then I'll go second matrix, edit my B matrix. Instead of making it a 2x1, it's now a 3x1, which is 9, 15, and 1. Then you quit out of it, and you go up and just do A times B. A inverse times B, I mean. Not A times B, but A inverse times B. And you'll get the answer of 2, -3, and 1. So if x is 2, y is -3, and z is 1, it works for every single equation. Okay? Easy peasy. Life with a graphing calculator is nice. Okay? So we got a bunch of the same types of problems. I don't think, oh, this one, 7. How in the heck do you do number 7? Well, what's the first matrix, or is the matrix in matrix form going to look like? Because you have x, y, y, z, and xz. So it's going to be 1, 1, 0 for z, 0, 1, 1 for y and z, and 1, 0, 1 for x and z. And then times x, y, z equals 5. Did this earlier today. Had a hiccup. 5, 3, 4. So on our calculator, second matrix, I'm going to edit A. That's going to be a 3 by 3 matrix, but it's going to be 1, 1, 0, 1, nope, 0, 0, 1, 1, and 1, 0, 1. That's my A matrix. My B matrix will be 5, 3, 4. And then if I quit out of there and then just arrow up to this again, so it reappears, 3, 2, 1. 3 plus 2 is 5. 2 plus 1 is 3. 3 plus 1 is 4. Okay? Systems of equations. Then you'll have a couple 4 by 4s. And then you'll have some word problems. Gonzalez Manufacturing borrowed $27,000. Part of the money was borrowed at 14%, part at 16%, part at 18%. The total amount borrowed at 14 and 16 was twice the amount borrowed at 18. Find the amount borrowed at each rate if the annual interest was $44,060. So, if you aren't paying attention now, pay attention for a couple minutes because you are not going to have a clue on how to do 10 unless you pay attention to this. Okay. So if the total money borrowed was $27,000, X plus Y plus Z equals $27,000. Okay? The total amount borrowed at 14 and 16 was twice the amount borrowed at 18. How do we write that down? Well, if I think 14 is X, 16 is Y, and 18 is Z, the total amount at that and that, so X plus Y, was twice the amount borrowed at 18% equals twice the amount at Z. The total amount at X and Y was twice as what Z was. Okay, so if you want them to be equal, you take 2 times Z to make them equal. So then, this equation doesn't appear like this. It'll become X plus Y minus 2Z equals 0. So now I have 2 equations. I need 3 equations because it needs to be a 3 by 3 matrix, right, Reese? So my third equation will be 0.14x plus 0.16y plus 0.18z, because that's the amount of interest involved, equals the total amount of interest, which was $44.60. Okay, so on my graphing calculator, second matrix, I want to edit my 3 by 3 to be 1, 1, 1, 1, 1, -2, and then 0.14, 0.16, 0.18, and then go second matrix to set up my B. So if I edit my B, it's going to be 27,000 for my first one, 0 for my second one, 44.60 for my third one. Second quit, go up here. And order is important. If you put B times A inverse, you'll get the wrong answer. A inverse has to be first and then B second. Trust me. A inverse has to be first and B is second. So 2,000, 16,000, 9,000. 2,000, 16,000, and 9,000. Okay? The last one, joint coin jar, okay? If nickels is N, dimes is D, quarters is Q, the total number of coins, if we add them up, is 189. If there are two more dimes and quarters, the number of dimes equals the number of quarters plus 2. That's two more dimes and quarters. Okay? If the total value of the jar is 2580, so then we go 0.05N plus 0.1D plus 0.25Q equals 2580. You type those matrices into your calculator. 1, 1, 1, 0, 1, negative 1, 0.05, 0.1, 0.25, and your B matrix will be 189, 2, and 2580. Because on this one, you say D plus or D minus Q equals